Hello everyone. Today we will be looking at an experiment, and this experiment is called modeling ionization. So what are models? Models are used to get a better understanding by visualizing the process. So we use models a lot in chemistry to get a better understanding, also to visualize the process. In the experiment we're doing right now, models are used to get a better understanding of the difference between the ionization of strong and weak acids. So we'll be comparing the weak and strong acids using models. Now let us get started. Here we have. So in this experiment, you will be making models of both hydrochloric acid as well as water. So to start off with, you'll be using a different colored plasticine bowls. So you would use different bowls. As you can see here, I have used green for chlorine, yellow for hydrogen, and also blue for oxygen. So you would use different colored bowls and also toothpicks to make 4 of each of the molecules. As you can see, I have made 4 of the water molecules and 4 of the hydrochloric acid molecules. And I have used toothpicks to connect the molecules together, to connect the atoms together in a molecule. Then what I do is I would remove the hydrogen atom from all the hydrochloric molecules and attach it to water. Now in this case, what I have done is I've taken out all the toothpicks from our hydrochloric acid molecule. So you would be left with a hydrogen ion and a chloride ion for each of them. Now you would attach the hydrogen ion to each of the water molecules. So you would use the toothpick you have already got and just attach it. So your models would look like this at the end. You would have 4 hydronium ions and 4 chloride anions left. So here's a hydronium ion. You would have 3 hydrogen atoms and 1 oxygen atom, and you would know that this has a charge of +1. So this is how you would model strong acids. Now we will compare it against weak acid. With a weak acid, we're taking HX, which is an example of a weak acid, and we'll take water as well. We'll make 4, as you can see here. So using the different colored plasticine balls and toothpicks, make 4 of each molecule. So you do the same step, but this time instead of hydrochloric acid, we're making the HX acid, which is a weak acid. Now then remove a hydrogen from one of the HX molecules and attach it to water. So in this case, we're not doing it for all 4 of the acid molecules. We're only doing it for one of them. So we're only taking out one of the toothpicks, and it's from only one acid molecule. So here we're going to be left with a hydrogen ion and an X anion, and this is going to be untouched. Then what happens is you're going to attach that hydrogen ion to your water. So we'll attach it to this water molecule, and we're going to be left with a hydronium ion and an X anion. So you're going to have 3 water molecules, 3 acid molecules, 1 hydronium ion molecule, and 1 X anion. So this is how you would model weak acids. So this was when we looked at experiments, and we looked at how you would model a strong and a weak acid. So we used plasticine balls and toothpicks, and we removed toothpicks and also put them back together to model the weak acid. Now let's move on to some questions. We have question 11 here. The question 11 states acid X is 0.1 moles per liter of hydrochloric acid, while acid Y is 0.1 moles per liter of sulfuric acid. Now I would write down the chemical formulas for each of them next to it, because this would make it easier later in the question. And they're the same concentration, as you can see. Now how does the pH of acid X compare with the pH of acid Y? Now these two would have different pHs. But remember, we learned that the pH is a concentration of the hydrogen ion. So we have the concentration of the acids That means the concentration of the hydrogen ions between these two acids should be different. So we'll consider each option one by one. We'll start off with option A. The pH of X is lower than the pH of Y, as X is monoprotic. Now we do know that X is monoprotic because HCl is a monoprotic acid. However, is the pH of X lower than the pH of Y? No, because there is going to be a higher concentration of hydrogen ions in sulfuric acid, it's going to have a lower pH, meaning it's more acidic. So option A is not the correct answer. Let's move to option C now. Option C states the pH of X is lower than Y, as X is diprotic. Now this has two wrong statements. One is that X is diprotic. X is not diprotic, as HCl is not a diprotic acid, it's a monoprotic acid with one H that it can donate. So this part is incorrect. Let's look at this part, lower than the pH of Y. Now again, we know that HCl is a monoprotic while H2SO4 is diprotic, meaning that there's going to be a higher concentration of hydrogen ions in the H2SO4. That means it's going to have a lower pH because it's more acidic. So clearly option C is not the correct answer. Moving to option D now, the pH of Y is lower than that of X, as Y is monoprotic. Now is Y monoprotic? No, because Y is H2SO4. There are two hydrogens that sulfuric acid can donate, making it a diprotic acid, not a monoprotic acid. So this is incorrect. So D is incorrect. Considering option B now, the pH of Y is lower than that of X, as Y is diprotic. Y is diprotic because it's H2SO4, meaning there are two hydrogens it can donate. The pH is lower because of the higher concentration of hydrogen ions compared to the concentration of hydrogen ions in HCl, making it a more acidic solution, therefore a lower pH. So B is the correct answer. Now let's move to question 12. Question 12 is also a multiple choice question and a very similar question indeed. In question 12, we have two acids again. One is hydrochloric, one is acetic acid, which is also known as ethanoic acid. They have different concentrations. The hydrochloric acid has a concentration of 0.1 moles per liter, while the acid Y, which is acetic acid, has a concentration of 1 moles per liter. How does acid X compare with acid Y? We again have four options here. Consider each option one by one. Option A, X is weaker and more dilute than Y. Now, is X weaker? It's not a weak acid because HCl is a strong acid while acetic acid is a weak acid. So that is incorrect. However, it is more dilute than Y. But because X is a stronger acid, option A is incorrect. Considering option C now, option C says X is weaker and more concentrated than Y. Now, X is not weaker and it is less concentrated. So both of the facts here are incorrect, making this the incorrect answer. Considering option D now, X is stronger and more concentrated than Y. Now X here, it is a stronger acid, but it is less concentrated than Y. Therefore, this fact here is incorrect, making D incorrect. Now considering option B, X is stronger and more dilute than Y. HCl, which is a strong acid, is going to be stronger than acetic acid, which is a weak acid. And it is more dilute because there's only 0.1 moles per liter, while there's 1 moles per liter of acetic acid. So option B is the correct answer. Now moving to question 13. Question 13 states, acid X and acid Y are both monoprotic weak acids of equal concentration. Acid X is a strong acid, while acid Y is a weak acid. Which statement about acid X and acid Y is correct? Again, we have four options here. Now here I would underline the key words. We know that they're both monoprotic and also that they're weak acids. with equal concentrations. But then here we have that little information that X is stronger than Y, meaning that X is going to have more hydronium ions than Y. So let's consider each option one by one. Option A, acid Y is completely ionized in solution. It is not completely ionized, none of the two acids are, because they're weak acids. So clearly option A is incorrect. Now moving to option B now. B says acid X is less ionized than acid Y. We know that acid X is a stronger acid than acid Y, which means that acid X is going to have more ions or more hydronium ions than acid Y. Therefore, acid X should actually be more ionized than acid Y. So B is incorrect. Now moving to option D, it says 1 mole of acid Y requires a greater volume of 1.0 moles per liter of sodium hydroxide for neutralization than 1 mole of acid X. Now this you have to kind of figure out with the concentrations. Here we have sodium hydroxide. Now we need to neutralize it. To neutralize it, we have to have this same amount of hydrogen ions. So the acid that has a greater amount of hydrogen ions will neutralize this faster. Therefore, this is incorrect. So D is incorrect. So let's consider option B now. Option C, sorry. Option C says acid X has a lower pH than Y. Because acid X is a stronger acid than acid Y, we know that X is going to have greater hydronium ion concentration, meaning it's going to have a lower pH. Using our equation, pH equals minus log to the base 10 of the hydrogen ion concentration. So remember this equation we learnt? So we're going to be using that, and from that equation you can see that acid X has a lower pH than acid Y. So C is a correct answer. Now let's move on to question 14. Question 14 has two parts. 3 different acid solutions with the same concentration were prepared and the pH of each solution was measured. So same concentration. So we have hydrochloric acid, acetic acid and citric acid here. Part A asks, what is the original concentration of acetic acid? Now to work this out, first you would realize that the concentration of the hydrochloric acid equals the concentration of the acetic acid. So to find out the concentration of hydrochloric acid, it would equal the concentration of the hydronium ions. Now the hydronium ion concentration equals 10 to the minus of pH. Now to work that out, you go back to that equation. So where pH equals minus log to the base 10 of the hydrogen ion concentration. Now first you would put minus signs on both sides. So for example, you would have minus pH. When you put a minus sign next to a minus sign, it becomes plus. So you would get log to the base 10 of the hydrogen ion concentration as here. Now what you do is you put 10 to the power of minus pH. So you put a base of 10. So your equation would now look like 10 minus pH, which equals 10, we're doing the same thing to both sides, log to the base 10 of the hydrogen ion concentration. Now this is a rule that applies with logs. So if it's 10 to the log 10 hydrogen ion concentration, it would eventually equal the hydrogen ion concentration. In other words, it equals a value here. So the hydrogen ion concentration would equal 10 to the minus pH, and that's how that equation there is derived. So you derive it from pH equals minus log to the base 10 of the hydrogen ion concentration. Now we know that the pH is minus 2.7. and that's from the value we're given. That gives us, if you put this into the calculator, you would get 0.0020 moles per liter, and this equals the concentration of the acetic acid, and there's your answer there. Now moving to part B. Part B asks which solution would have the lowest concentration of hydrogen ions, and also asks why. So you would have to first identify it and then provide an explanation for why you chose that answer. So the answer is acetic acid. Now why? Because look at these pHs. pH 2.7, 3.7, and we have 2.9. Now 3.7, which is acetic acid, has the highest pH, meaning that the hydrogen ion concentration is the lowest when there's a highest pH. And the pH of acetic acid is the highest, and therefore the concentration of the hydrogen ions is the lowest. And that's your answer there. Now let's move on to question 15. Question 15 says, in the following pairs of solutions, predict which solutions. There's part 1, which has the higher concentration of hydrogen ions. Part 2 is a better electrical conductor, and part 3 is a stronger acid. Now there's a part A, which is the comparison of these two acids. That's hydrochloric acid as well as the acetic acid. They have the same concentration of 0.1 moles per liter. Now what's part 1? Has a higher concentration of hydrogen ions is our strong acid, hydrochloric acid. Because hydrochloric acid ionizes readily compared to our acetic acid, there's going to be a higher concentration of hydrogen ions. Now part 2, it says, is a better electrical conductor. What conducts electricity is charged particles. Now these H pluses and Cl minuses do conduct electricity, while the acid molecule doesn't. So which one of these ionizes more readily? HCl does. So hydrochloric acid would be the better electrical conductor. Part 3 is a stronger acid. We know that HCl is a strong acid, while acetic acid is a weak acid. Therefore, hydrochloric acid would be the answer for part 3. Now, moving on to part B. Part B says 0.1 moles per liter of sulfuric acid and 0.1 moles per liter of HCN. So here are our two acids, and again we are going to compare them. One has a higher concentration of H+. Again we get sulfuric acid because sulfuric acid, a diprotic strong acid, is a better electrical conductor. Again sulfuric acid, because it's diprotic, has 2 hydrogen ions, again meaning that there's going to be more charged particles, and is a stronger acid. Again we have to go with sulfuric acid because sulfuric acid is a strong acid. Now this brings us to the end of the section of strength and concentration of acids. In this section we looked at the strength and the concentration of acids, and also we did an experiment to model this procedure.